Okay, so for 7.2 day one, we're going to look at rational graphs, and it's fun to look at these on Desmos. So if you haven't, try to graph some of these on Desmos just to see what they look like. Okay, these are called rational graphs. We're thinking fractions here. They have two symmetrical parts called branches. This is one branch, this is the other. There's a horizontal asymptote at y equals 0. Right now you can see it's not crossing the x-axis. There's a vertical asymptote at x equals 0. So this is the y-axis. The domain is all the real numbers except x cannot be 0. And if you look at the graph, it goes from left to right. It stops at x equals 0, and then same here. Or if I look at the equation, I know there can't be a 0 in the denominator, which is why x cannot equal to 0. In the y direction, the graph starts really low, it goes up, but it won't hit 0. It'll hop over and end up here. So we're going to be looking at graphs that have two different pieces, and they have specific asymptotes. Okay, so let's look at these graphs. Okay, the first thing is in the denominator, there's an x, which means the denominator cannot equal to 0. So let's look at the bottom first, actually. So that means the bottom cannot equal 0. So for the domain, I'm going to say the x can't be 0. The x can't be 0 because there's actually an asymptote there. So the vertical asymptote is at x equals 0. When we draw it, we normally draw a dashed line, although when it's on the axis, it's very hard to see. Okay, generally, the parent function has a horizontal asymptote at y equals 0, right here. So it's not going to cross right here. So the asymptote is y equals 0. The range is that the y values cannot equal, they're everything but 0. Okay, now I know there's going to be two branches. I want to graph them. They're normally symmetric, like maybe one's here and here, or one's here and here. So I'm going to plug in a couple values in order to figure out where those pieces are. I normally pick ones very close to the vertical asymptote. The vertical asymptote is at 0. So I'm going to plug in easy numbers to the right of this asymptote. So I'm going to plug in 1 and 2, just because they're easy to plug in. 1, 2. If I plug in 1, x is 1, I get 2 divided by 1 is 2. If I plug in 2, 2 divided by 2 is 1. Let's graph those two pieces. 1, 2, 2, 1. And that's telling me which direction that branch is going to go. It cannot cross the asymptotes. So it's going to go this way, and it's going to approach the vertical asymptote. And then on the bottom part, it's going to approach the horizontal asymptote. And that's actually a very good graph. Okay, now there's two branches though, so I need to also graph the left branch. So this is my vertical asymptote at 0. I'm going to plug in a couple numbers to the left. I can pick anything, but the easiest are -1 and -2. -1, -2. Okay, so if I plug this x value into here, 2 divided by -1 is -2. If I plug in -2, 2 divided by -2 is -1. Let me graph those, -1, -2. -2, -1. It's only 2 points, but the asymptotes are actually more important. So I can tell that this graph is going to go towards the vertical asymptote, and it's going to approach the horizontal asymptote, but it cannot hit y equals 0, which is why it will always level off. Okay, let's go ahead and look at the next one now that you've kind of seen how we're going, what our strategy is. Okay, vertical asymptote, I'm going to look at the denominator. I know I can't divide by 0, so x cannot be 0 for my domain, which means it can't be 0 because there is a vertical asymptote there. Again, I'm going to draw it as a dashed line, but because it's on the axis, it's really hard to see, so we sometimes omit that. Okay, generally these have a horizontal asymptote at y equals 0. Since there's an asymptote there, y will not equal to 0, so I'm going to draw that in. Okay, now I just want to see which way the branches are going. So vertical asymptotes here, I'm going to pick an x value to the right of the asymptote. I'm going to pick 2 actually because the directions ask for 2, but sometimes we only do 1. Okay, so this is 0. Let me plug in 1 and 2. 1, 2. If I plug in 1, I have -5 divided by 1, so I get -5. If I plug in 2, I get -5 divided by 2, which is a fraction, but I can probably estimate it. Okay, so 1, -5. 1, 2, 3, 4, 5 is down here. When I plugged in 2, I got -5 over 2. You can put it in your calculator and get -2.5, or you can say 2 goes into 5 2 times plus a remainder. Either way, at 2, I'm going to go down 2.5. Okay, even though it looks a little different, because of the asymptotes, this is enough information. So this is going to go down towards the vertical asymptote, and it's going to go up towards the horizontal. It seems like it's far away from it, but it will keep getting closer and closer and closer. Okay, so now I'm going to plug in a couple numbers on the left side. The vertical asymptote is at x equals 0, so I'm going to plug in -1 and -2. If I plug in -1, I have -5 divided by -1, so I actually get +5. Okay, if I plug in -2, -5 divided by -2 is negative +5/2. So -1, 1, 2, 3, 4, 5. -2, 2.5. Okay, and even though they look a little out there, they should go up towards the vertical asymptote and then down towards the horizontal, but then they won't cross it, so it tells me the shape of the graph. Okay, let's do the same with some rational graphs that have a horizontal translation. Okay, the way I do them every time though is going to be the same. So I'm going to go ahead and look in the denominator. I want to see what makes the bottom 0. For my domain, I know x minus 3 can't be 0, so x can't be 3. So for my domain, I know x can't be 3. It can't be 3 because there's a vertical asymptote at 3. So my vertical asymptote is x equals 3. So at x equals 3, 1, 2, 3, I'm going to draw a vertical asymptote. And this one is very important because it's not on the axis. Generally, the horizontal asymptote is at y equals 0, and it will be today. When it changes, we will change it. Okay, so y equals 0. Okay, now I want to pick a couple points on each side because it's asking for 2 points on each branch. Again, sometimes we'll only do 1. Okay, since this is x equals 3, I want to pick a couple points to the right of x equals 3. So maybe 4 and 5. Okay, I'm going to plug this into right here. So if I do 1 over 4 minus 3, that's 1 over 1. So I'm going to get 4, 1. If I plug 5 in there, I get 1 over 5 minus 3, which is 1/2. 1, 2, 3, 4, 1. 1, 2, 3, 4, 5, 1/2. Okay, and again, they don't look like super helpful points, but they are, because along with the asymptote, I know it's got to go up towards the vertical and down towards the horizontal. Okay, that's one branch. This is my asymptote. It's dividing my branches. So let me plug in a couple numbers here. It's like 2 and 1. Okay, and I'm going to plug the x value in here. And you can do it in your head if you would like. 1 over 2 minus 3. That's 1 over -1, so -1. Okay, 1 over 1 minus 3. 1 over -2. So at 2, -1. At 1, -1/2. And again, they don't look like much, but once I use the asymptotes, you know it's going to go up towards the horizontal and down towards the vertical. It's actually enough information to get a very good graph. Okay, let's try the next one. Okay, I'm going to do the vertical asymptote first. For domain, I know that x plus 2 cannot equal to 0. So x can't be -2. That's for my domain. It cannot equal -2 because there is a vertical asymptote at x equals -2. So at x equals -2, boom, boom, vertical. And it's very important for our graph, so we're going to put it there. The parent function has a asymptote at y equals 0. So let me draw that in. Okay, because it's asking for 2 points per branch, I'm going to pick 2 points. My vertical asymptote's at -2. So I'm going to pick a couple on the right, a couple on the left. So if this is -2, let's plug in -1 and 0. -1, 0. And I'm okay if you do this in your head, just be careful. Okay, so that's 3 over -1 plus 2. What is that? 3 over 1, which is 3. Okay, how about if I plug in 0? Oh, 3 over 0 plus 2, 3 over 2. Let's try these. -1, 3. 0, 3 divided by 2 is 1.5. Okay, and again, use your asymptotes. It's going to go up here, and it's going to level off down here. Okay, let's pick a couple numbers to the left of my vertical asymptote, -1, -2. So -3, -4. And you could use different points. These ones just happen to be convenient. Okay, so if I do 3, -3 plus 2 is -1, so -3. 3 over negative 4 plus 2. 3, negative 2, so negative 3, 1, 2, 3, negative 4, 1, 2, 3, 4, negative 1.5. And again, use your asymptotes to guide your graph. Okay, last, what can we add? Vertical translation. Okay, this one is going to have a vertical translation. So we'll see how that affects it. Okay, but I always start the same. I'm going to start with the vertical asymptotes. So I know domain is x can't be 0. And the reason it can't is because there is a vertical asymptote at x equals 0. So that's what I'm going to get first. Okay, generally the horizontal asymptote is at y equals 0. But in this case, it's going up 3. So instead of y equals 0, y equals 3. So on the y-axis, 1, 2, 3, y equals 3, I'm going to draw the horizontal asymptote. Okay, I'm still going to pick 2 points on either side because it's asking for 2 points on each graph. Eventually, I will only ask you for 1. Okay, so x equals 0 is my vertical, so let's plug in 1 and 2. 1, 2. And it's okay if you do it in your head, but I'm going to do 2 over 1 and then plus 3. So that's 2 plus 3 is 5. And then I'm going to do 2 over 2, which is 1 plus 3 is 4. 1, 1, 2, 3, 4, 5. 1, 2, 1, 2, 3, 4. Okay, we're way up here, but again, I'm going to use my asymptotes to shape it. Okay, x equals 0 is my vertical. Let's plug in negative 1 and negative 2. So 2 divided by negative 1 is negative 2, and then plus 3 is 1. 2 divided by negative 2 is negative 1, plus 3 is 2. So negative 1, 1, negative 2, 2. And if we didn't have the asymptotes, that would not be enough. But with the asymptotes, it's going to go down this way. It's going to go up this way. Okay, last one. Okay, start with the vertical right here. X minus 1 equals 0 tells me my vertical. X minus 1 doesn't equal 0. Tells me my domain. Either way, x can't be 1. And there's a vertical asymptote at x equals 1. Okay, generally, the horizontal asymptote is at y equals 0, but since there's a minus 2, it's going to go down 2. So now it's at y equals negative 2. Okay, let's plug in a couple points. My vertical asymptote's at 1. Let's plug in 2 and 3. Okay, so negative 4 divided by 2 minus 1 is 1 minus 2. Negative 4 minus 2, negative 6. Negative 4. 3 minus 1 is 2. Negative 2 minus 2, negative 4. 1, 2, 1, 2, 3, 4, 5, 6. 3, negative 4. Okay, again, use your asymptotes. So it's going to go down, and it's going to level out up here eventually. Okay, let's plug in for the second branch. Vertical asymptote is at 1, so let's go to 0, negative 1. Okay, if I plug in 0, I have negative 4. 0 minus 1 is negative 1. What is that? Positive 4 minus 2, 2. Negative 4. If I do negative 1 minus 1, I get negative 2. So that's positive 2 minus 2, 0. Okay, and then let's go ahead and sketch our left branch. Okay, and then now we're getting an idea for the shape of rational graphs.